Okay, so just 2 minutes on worksheet 1. Okay, these are basic percentages. If you want to practice these, there's always the BBC bite size, which I've referred to a couple of times. All right, so we want to find a percent of a number. So if we want to find 23%, we should be really saying 23 over 100, because that's a definition of what a percentage actually means. But we can shortcut this and say it's the same as multiplying by 0.23. If you divide that into that. And we learn pretty quickly when we work with percentages that the first 2 digits after the decimal place is the number of percentages. So 0.23 times 670 is indeed 154.10. So here, for instance, we've got a decimal place, but that's all right because this is the same as multiplying 0.157 times 7,000. Yeah, the first 2 digits after the decimal place represent how many whole percentages. So this one in the third position is 0.7. Here we've got to, a television costs 595 plus VAT. Well, in the next worksheet, we're going to look at percentage change. So let's do this from first principles. We're going to first find 17.5% of 595. So and that equals, quickly look at my calculator, 0.175 times 595 equals 104.13 to 2 decimal places, and then we'll just add that VAT amount to the total amount. So here's us now adding it back, 104.13, which should equals 996. Oh, I have to come all the way down to find that out. There it is. Anyway, that's all I'm going to say for this one. So worksheet 2, this is about percentage increase and decreases. Now it's all in my lecture slide, so that's probably the best place to look if you want to learn this. I'm not going to repeat all of it. This is just a reminder to help you with this worksheet. All right, so this is about adding, for instance, 20% or deducting 20%. We could do it longhand. We could find 20% and add it or subtract it. But what we learn in class is that we can shortcut that. And this is quite important to get us starting to think about things like compounding. Yeah. So if we want to add 10% to something, in fact, I think I've already explained this one. Yeah. To add 10%, we multiply it by 1.1. The first one keeps the same original amount, and the 0.1, when multiplied by it, adds 10%. Yeah, the 0.1 represents 10%. So how do we add 10% to 320? Well, that's 320 times 1.1. How do we add 15%? Well, here we have to multiply 80 by 1.15. So this is finding 15% and adding it. Okay, so it's nice and clever. One simple 1.2. All right, so the price of 6,800 cards reduced by 10%. All right, so now we're reducing. So we want to multiply it by something less than 1, otherwise we'll get a bigger number, won't we? So if this is the original price, we want to multiply it by something that just gives us 90% of the original amount. So it's definitely going to be a number less than 1, and it's going to be 0.9. Yeah, that only gives us 90% of that, so it leaves that 10% off, the 10% that the price has lost. So let's go to the next page. I'm going to have to do all these first. Here's the next page. Let's do some more decreasing. So decrease 42 by 15. Right, so this time we're going to multiply 42 by 0.85. Yeah. Taking off 15% is the same as saying, just give me 85% of the original, which is what we're finding there. Here we would find 890 0 times 0.82. Again, taking off 18% is the same as just finding 82%. Those two add up to 100. And let's do one more. In a sale, normal prices are reduced by 7. The normal price for camera is 89. Work out the sale price, so we now have to reduce it by 7%, so we're going to multiply it by 0.93, which is the same thing as subtracting 7. Okay, worksheet 3. This is about simple compound, well, I shouldn't say the word simple, basic compound interest questions. Simple interest is something different. All right, so this is compounding. This is the normal kind of interest accumulation that we used to in our bank accounts, and very important to financial maths. It sort of underpins a lot of the other stuff we're going to do. All right, so this is going to be very quick because actually the worksheet has the worked examples in it already. So I'll probably just do 2 of these. Right, let's look at this one. Sarah puts 8,600 in a bank. The bank pays compound interest of 3.8% per year. Calculate how much she will have after 4 years. So this is the classic compound interest formula. Her principal is 8,600, and we need to multiply that. I'm going to put it in brackets, you don't have to. By a compounding factor of 1 point. Just like before, we need the 1 point to keep the principal amount, and we need to add 3.8%. So we're going to add essentially 3.8%. So multiplying by that will add just once, add 3.8% to 8,600. So that's what will happen at the end of the first year. But we're going to do it for 4 years. So we need to multiply by that compounding factor 4 times. And how do we do that? Well, that means we're raising it to the power of 4. So we're multiplying it by that, by that, by that, by that. So we're going to do it sort of 4 times essentially. And that will give us, oh, wrong button. That will give us, yeah, so here we are, 8 to the power of 4. Well, that's a bit eeny-weeny, isn't it? Can't see that very well, but that's how much we're going to get. So let's just look at this one. Puts 7,900 in. So the compounding is going to be 0 to 4. Remember, the first 2 digits after the decimal place is how many whole percent. There's only 2% here. So we need a 0 there as a sort of space filler. For 3 years, and that should give us that amount. Oh, but here they're saying how much interest does she pay? So that will give us how much she will have in her bank account at the end. So if we want to calculate the amount of interest, then we'll take so the total she will have in the bank account after 3 years, subtract it from the amount she had to begin with, and that tells us she earned that amount. Okay, so what's the next one? Oh yes, we should do one of these. So this one is about depreciation. So the rate of depreciation of a particular band of computer is 65% per year. If the cost of computing when new is 650, how much is it worth in 10 years? So here we want to take 650, and we want, so for the first year, they want us to do it for 2 years. For the first year, it is like multiplying by 0 point, and I'm looking at 65% here. It's a pity these two numbers look too similar. 65% is the same thing as multiplying by, okay, like we did with the previous worksheet. If we multiply by 0.35, it's like saying I only want 65%. So that's how much depreciation we get in the first year. How much do we get in the second year? Well, we do the whole thing again. Now we multiply by that again. So that's the sum we need to do. Now 650 times 0.35. How many years will it take? Well, here we can just do it 1 year, 2 years, 3 years, and find out how long it takes before we get that amount. So that's So is it worth doing this? Let's see. So we've got 17,000, which pays 4% compound interest per year. So it's like saying every year we're going to multiply it by that. How many years will it take before he has that or she has that? Well, we'll just have to keep multiplying it. So here's me putting 17,000 in my calculator, multiplying it by 1.04. So it seems after the first year, I will get, so year one, I will have, I can't read it, 17,680. No, not enough yet. So I'm going to multiply by another 1.04. So this is like saying times 1.04 squared. That's going to give me a year two amount of 183. So I'm getting up there. Well, this is year two. 18387. Year two is 18387. So probably we need 3 years worth of. So at year three, we will have, I'm going to multiply that whole thing by 1.04 again, and we get year three, we get 19122. So the answer to that question is, it takes 3 years to get that amount.